Welcome to the video on dilations, the last of the transformations that we're going to be studying in geometry this year. So what exactly is a dilation? Simply put, a dilation is a transformation that produces an image that is the same shape as the original, but a different size. So I can go ahead now and fill that in on my notes packet, and you should also. What a dilation will do is it will either enlarge or it could possibly be that it may shrink the original figure using a given factor. And the scale factor is what it is that it determines how much larger or smaller our object becomes. Now that said, a scale factor that's larger than 1 means our object will be multiplied and will therefore increase in size. So again, any scale factor larger than 1 increases the size of our object, whereas a scale factor between 0 and 1 means that our object will decrease in size. For our course this year, all of our dilations are going to use the origin as the center of our dilation. So I'd like you to think for a minute and ask yourself the question, is a dilation an isometry? How would you know? I don't really care if you get the answer to this question wrong, but I would like you to pause the video right now and answer that question. If you know what an isometry is, it should be a fairly simple and straightforward answer. If you need to, get your notes out and look at what an isometry is in order so that you can answer the question. All right, so let's go ahead now and take a look at what this would look like on the coordinate plane. We're given this triangle ABC with the following coordinates. It wants us to graph and state the coordinates of the new triangle, which is going to be the image of the original triangle, under a dilation with scale factor 2. All right, so there were a couple things that I just read that I really want to pay some close attention to here. First things first, it's not only asking us to graph the new triangle, but it's also asking us to state the coordinates of this new triangle. The other piece of information which I read, which is pretty interesting, is that capital D subscript 2. The capital D subscript 2 tells us, or stands for, the D tells us that the transformation that we're going to be completing here is a dilation. And the subscript of 2 tells us that the scale factor that we're going to use here is 2. Keeping this in mind, I want you to ask yourself right now, is the new triangle going to be larger or smaller than the original? And how do you know? What do you suspect? All right, so hopefully at this point you've made a prediction about what you think might happen to our triangle. Let's go ahead and graph our triangle and find out. So there's point A. There's point B. And there's point C. So if I did this right, it's probably going to be a funny looking little triangle. So I'm going to go ahead and write down my original coordinates. We said A had coordinates 1, 2. Point B had coordinates 0, 4. Point C had coordinates 4, 1. Here's what a dilation will do. Under a dilation with a scale factor of 2, what it will do is it will take and it will multiply each of the coordinates in our ordered pair in such a way that for A, our new image, A prime, will have coordinates 2, 4. And to get that, all I did is I took the original x and y values, these guys right here, and since my scale factor was 2, I multiplied each of those by 2. And if I go through and I do that for each of my coordinates, I find that the image of B prime under a dilation with a scale factor of 2 is 0, 8. And C prime, after a dilation with scale factor 2, becomes 8, 2. So I'm going to go ahead and plot those coordinates of my new vertices. So there's A prime. E prime moves right there. C prime moves right there. So if you had predicted that the new triangle would be larger than the old triangle, you were exactly right. How did you know? Well, the scale factor of 2 was larger than 1, meaning that the size of our triangle increased. All right, lastly, I want to make sure that we did everything that we were asked to do. It asked us to graph the triangle. We did that. Done. It asked us to state the coordinates. Did that. Done. So now I know that I have fully completed all of the stages or all of the steps in this particular question. All right, I'm going to move down to the bottom of the page at this point. This gives us triangle Jim, and it gives us some coordinates. It asks us to graph, again, so I'm going to keep in mind exactly what it is that I need to complete here. I need to draw a graph. I also need to state some coordinates of triangle GYM prime, the image of triangle GYM after a dilation with a scale factor of 1/2. Again, I'm going to ask you to make a prediction about our new triangle. Do you think that the new triangle will be larger or smaller than the original triangle was, and how come? Well, let's find out. I'm going to go ahead and graph the vertices of that triangle. So there's the triangle that we're starting with, or the original triangle. And I want to go now and I want to dilate each of these coordinates using a scale factor of 1/2. So if I'm starting with point G, whose coordinates were 2, 6, and dilating it by a scale factor of 1/2, again, what that means is that I'm going to take my x coordinate and take my y coordinate and multiply each of them by 1/2. And in doing so, I realize that the image of G, or G prime, is going to have coordinates 1, 3. Repeating that for each of the coordinates in my triangle, y had starting coordinates of 6, 4. After a dilation with a scale factor of 1/2, its new coordinates are going to be 3, 2. And then vertex M with coordinates 4, 0. Under a dilation with a scale factor of 1/2 becomes M prime with coordinates 2, 0. I'm going to go ahead and plot those new points. And if you had made the prediction then that our new triangle would be smaller than the original, you were right on the money. All right, the questions at the bottom of the page I'm going to ask you to try for tomorrow. If you get them wrong, you get them wrong, no biggie, but I would ask you please to commit to an answer. When you come into class tomorrow, we'll work on more of this with the dilations.